this. Let's go this one. All right. Let me see. Okay, I think that image is fine for now. Let me see. So, as far as announcements, we're just kind of moving forward with the material. I think this week we're doing sections 3.3 and 3.4. So I just made the video lecture for this like a few hours ago. It's a little bit dicey, so do the best you can with it. But we can kind of work through some homework sets. Again, my intent is to take class time to answer questions. So, if you have questions during class, is the best time to get them answered. Otherwise, we're just going to kind of make our way through the homework. So, yeah, I know the homework might be a little intense, but that's why we do unlimited attempts at it, because it is a little intense. Um, you have to do the best you can with it. Okay. So we're going to take some time to get through as many questions today, unless you guys have specific questions. You know what? Let me see that I loaded it. Okay, that looks good. So then let's go here. If I do like this, that's not the right one. Properties. I'm coming, guys. Properties. We're working here. Okay. Let's go here. Let's change. Let's do new share. That one and this one. No, not that one. Not that one. This one. Yeah. Okay. That's fine. Share the two. Hopefully that's not frozen. Yeah, I don't know. I think my stuff because I'm still running from my previous class, like, and so I guess it just is like burning out. Like this, right? So hopefully, I don't know why that looks like that, but let's reboot it. Uh-oh, that's screen recording. I don't know, really recording. Come on. Yeah, we're gonna see how this stuff works because it's like I need more downtime between classes. That's why it's like it needs to be like off and like restarted. All right, I'm gonna let that be for right now. It does need to be adjusted some. I'm not gonna worry about that just yet. I think I could give him. Let me make sure I gave him credit. All right. So that's still booting up a bit. Let's hop over here and let me go adjust my share so you guys can see it. That one. Yeah, I think you can see it, right? There's that one, and you need this. Come on, share. Okay. Try one thing there. Okay, I'm gonna let that be while we work. Okay, so let's kind of start making our way. Oh, come on. It's the biggest of it. That's what I need. Okay. Yeah, I don't know. It's just temperamental. Like it just has to like warm up and who else? So I got one of them. But then the other one is okay. The other thing is I also have students coming in, so then that you have to kind of address that. Okay. Now, why does it look like this? What if I go like this? What if I exit out of this? Come on. Hmm. Where's this out? Oh, and then yeah, it's just technology being technology, really. Give it just a moment, cause it's trying. Let me do this. Let me quit this. Let's try it one more time. I'm coming, guys. Cancel. New. So yeah, I want to say that these questions do kind of take a little while, or at least a couple of them that I've come across, and it comes like when we go to do like the second derivative. I think I gave the student credit. Hmm. Let me reboot this. This one. Okay, that's not even the one I wanted. The one I wanted was this one. Hmm. All right, I'm gonna just go with this for right now because I'm gonna kind of get started. And we are working here. Let's just, yeah, let me go ahead and do my new share because I wanted that one and this one. Share. And we'll fix the other one momentarily. Like my the tablet's not displaying properly, but I'm not going to worry about that right now. And I'm going to kind of get to a question regarding 3-3. So I'm going to kind of go forward until I see something that says 3-3. Because these are all augmented, or these are all reviews. And so we don't have a lot of time together. So I'm going to just kind of. So in the pre-recorded lecture, I went into as many details as I could about what was relevant or pertinent. It was a little dicey. I did kind of like, I forgot like a negative somewhere, and it was throwing things off. And it took me a while to find it, but I eventually found it. So you just have to do the best you can. But we'll do what we can together here and now. Okay. So it says determine the vertical asymptotes. All right. So now we're looking at graphs of like rational functions and a few other functions. So with the rational function, the vertical asymptotes, they're going to be like these vertical dash lines, where as you get closer and closer to whatever that number is on either side, y as x gets closer and closer to whatever that number is, y goes off to either positive or negative infinity. And those occur whenever, if we're evaluating a function, whenever we get like some number over zero, that's where we're going to have a vertical asymptote. If we get 0 over 0 on the graph, that's going to be a hole or a gap. So like for instance, for this one, the vertical asymptote is going to occur when the denominator is 0, right? So if we set the denominator equal to 0 and solve, we get x equals 1. Because if we plug in 1 into this function, we're going to get what? 5/0. So because we have a number over 0, that's an indication of a vertical asymptote. So it has one vertical asymptote of x equals 1. Type an equation, right? X equals 1. Okay? Let me see. Let's try another one. Determine the vertical asymptote. Okay, so basically set the denominator to 0 and solve. I think if we were to set this to 0 and solve, we would get plus or minus 12. So it has 2. Wait, yeah, 2. Right? So there are two values of x that make the denominator 0 here after simplification. So it has two vertical asymptotes. The leftmost is x equals negative 12, and the rightmost, is that working? Okay, is x equals 12. So what I did there, again, I set the denominator equal to 0 and solve. Well, first you simplify, but nothing cancels here. So then you set the denominator to 0 and solve, and that's going to be your equations or your asymptotes. Same thing here, right? Two numbers that multiply, if we set the denominator to 0 and solve, I think it's 5 and 2. Notice that 5 times 2 is 10, and 5 plus 2 is 7. So if we were to write this out, the x plus 5s would cancel, and we would only be left with x plus 2 on the bottom. So that means it has one vertical asymptote of negative 2. Right? All I did was set the denominator equal to 0. So let me write it out. Let me write it out because that's too much to hear. And so this wants to act up. Let me see if I can get this to work. So I think if I maybe like reboot this, sometimes that'll do it. I think sometimes if I go like this, and I am working here. Come on, you can do it. I need you to cooperate. Come on. And like this display thing is like very temperamental. I don't even know fully understand how it works, like what's causing it to like delay. I think honestly I probably should just reboot everything, but I don't want to do that just yet. And it always does this. Like I'll have stuff loaded, but then I guess like if you do it too early, it kind of makes the computer slow down, and if you do it too late, then you're late. You know. Hmm. I don't want to have to reboot my computer. Not right now. Let's do a new screen recording. Yeah, I've done that already. There we go. Ugh. Okay. New share. Where is it? This one. Share. We'll be lucky if this stuff makes it. It's like really dragging. I'm gonna do full screen, and let me check that people at home can see as well, or here. Okay, that's fine for now. Okay, so it's a little bit laggy. I think I just need new equipment and probably more equipment. I still hadn't figured. I gotta figure out how to make this a smoother process. It's still like lagging in the display. So usually when that happens, what I have to do is like this. Come on. Hang on. Okay, it's looking okay this time. And okay, I think we finally got it. So, and let me check one other thing that looks proper. Okay, I'm not gonna worry about it. Okay, oh, we need to take some notes. So let's hop back over to Pearson. I want to make sure it's displaying. Okay, I think we're finally cooking now. Yeah, I don't know. It's just temperamental. Like the stuff has been open, but if you have it open too long, I think it wears it down too. So we want to set the denominator. Okay, so let me see. This is question number 13 from this assignment. I'm just going to say find the vertical. I'm just doing a shorthand vertical asymptotes. Okay, if they exist. We have x on bottom. We have x squared. We have x squared plus 7x plus 10. On top, thank you. Stop. On top, we have x plus 5, and this is f of x. Okay, let's hop over to the tablet and see what's going on. Okay. All right, so if we're trying to find the vertical asymptotes, so first we need to simplify, right? Because if we just set the denominator to 0 and solve, we're going to get two results. In order to simplify this, I need to factor that denominator. So I'm going to do that off to the side. So if we have x squared plus 7x plus, what was that? That's not 0. Plus 10. Let's just do this. Okay. We want to factor that, so then we should be able to factor it into something of this form, where we have the double parentheses. So we're looking for x and x. I think we got it earlier. We said plus 2 and plus 5. Notice that 2 times 5 is 10, so that checks out. 2 plus 5 is 7, so that checks out, right? So then if we go back to this f of x, let me just copy and paste. So if we're back working here, okay, that means if we factor the denominator factors into x plus 2 and x plus 5, and we still have the x plus 5 from, from the original. Now these guys cancel, right? So we may have been tempted to say, oh, -2 and -5 were vertical asymptotes. But actually, -5 is going to appear as a hole or a gap in the graph, right? Because that's going to give us 0 over 0. So whenever we have 0 over 0, that's a hole or a gap. To be a vertical asymptote, we got to get some number over 0, right? So then from here, you get that the vertical asymptote occurs when x is -2. I just set the x plus 2 equal to 0 and solve. You get -2. Okay. Let me do this, and we're gonna go back and check our work. So these can be a little bit, not these questions, but some of these questions do get a little. I have an urge to say verbose or wordy, but that's not the right word. But they can be lengthy. They can take a while. Okay, so let's hop over to Pearson. I think we got one vertical asymptote, and we got x equals -2. Okay, and we'll see, like, we'll get a pictorial representation of these notions and ideas. Determine the vertical asymptotes. So, okay, natural log. If you think of the general graph of natural log, it has a vertical asymptote, which is the y-axis, and it goes off to the right. Trying to think how this affected. Okay, so in general, natural log has to be greater than or equal to, this inside part has to be strictly greater than 0, right? Because we can't take the log of 0 or negatives. So, let me see. I was basically going to find the domain, but I was going to do set this inside part strictly greater than 0 and solve. Now I don't think I've done this one with this text, but I'm just going to work it based on the way I see it, and then go from there. This is question 14. We're asked to find any vertical asymptotes. Okay. So I'm just using pure definition of find the domain of a log function. So if we're given f of x equals the natural log of x squared plus 25. Now I don't know that this is the official way that the book does it. This is just the first thing that came to my mind. Okay, let's hop over to the tablet and see. So again, in general, we can do orange, I guess. So this orange thing, for a log function, has to be, in general, the domain of a log is going to be this orange thing has to be strictly greater than 0, right? That's the domain of log. So the vertical asymptote for log occurs when x is 0, which is the y-axis. So I'm going to solve this. Actually, I think this is always positive, right? Because if you solve for x, subtract 25, when you go to take the square root, you'll get the square root of a non-real number. So this is always greater than 0, right? No matter what x we choose. If x is 0, we're positive. If x is negative, we're positive. If x is positive, we're positive. So this one, the domain, should be all reals. Yeah, we're gonna go all reals. Vertical asymptotes. So wait, that's the domain. The question was on vertical asymptotes. Anything undefined. Normally it would be x equals 0, but I think it's not there. I'm gonna say no vertical asymptote. That's what I'm getting from this. Okay. Let's hop over to Pearson. And before I submit, I want to see. I got no vertical asymptotes because we can't get this guy to be 0, right? I want to see how the book explains it before. Oh, they don't have one. Man, this one is like infamous for that. Okay, I'm gonna go no vertical asymptotes here. Usually it's a lot better. Okay, let's just try another one. Also, if you have questions, feel free to type in the chat. You guys can hear me. You can try unmuting yourself, but I think my audio might be turned down. So just use the chat, and then I'll turn it back up once we start using it. No, I don't know why. Anyway, let's keep going. We're here, and we want to keep working here. Determine the horizontal. Okay, so horizontal asymptotes for our discussion. Now, you may or may not have been exposed to this in college algebra. I'm curious as to if Morehouse, with their revamping everything, did they go back to this? But in college algebra, like if you're doing rational functions, like there are three tests that you can do for horizontal asymptotes. I think this book, the way it articulates it, is if the degree of the numerator is less than or equal to the degree of the denominator, then you're going to have a horizontal asymptote. Um, let me try to mimic the way the book does it. So let me start by taking some notes because I'm trying to think of the simplest way to walk you guys through this for this context. So if we go to question, this is question number 15. I'm going to say find any horizontal asymptote. Okay, so that means as x goes off to either positive infinity or negative infinity, what happens to our y, right? So then we're going to consider f of x 14x minus 9 under 6x. Okay, let's hop over to the tablet. Okay. So notice here that the degree of the numerator is equal to the degree of the denominator. So from college algebra, it just said it as a blanket statement. Oh, it's the horizontal asymptote is going to occur from the ratio of the leading coefficients, right? So it should be 6 over 14 becomes what, 3 over 7, right? But for this text, we should get the same result. But what we're gonna do, we want to consider. So horizontal asymptote is talking about long-term behavior, as x goes off either to the far right or the far left, right? So first, let's consider the limit as x goes off to the far right, positive infinity of the original function, all right? This is what we want to consider. So this is going to be the limit as x goes to the far right. We got this 14x minus 9 under 6x, okay? So now, to evaluate this, what we're going to do, we're going to factor out a power of x, whichever, the largest power of x, right? So in this case, it's just x to the power of 1. We're going to factor that out from the top and the bottom. So this is going to give us the limit as x goes to infinity. We're going to have x times 6 over x times, it's going to be 14 minus 9 over x, right? I factored out x from every term. So then when we do this, these cancel, right? This is okay to do. And now if we take the limit, we pass the limit as x goes off to infinity, what do you think happens? See, like if we were engaging, what do you think happens to this term, right? You got a fixed number and the denominator keeps getting bigger and bigger and bigger. So if you have a fixed number over a forever expanding denominator, then this guy essentially goes to 0, right? And the only thing that's left is going to be 6 over 14, which reduces down to 3 by 7, okay? Okay. Let's see, is that ready to go? Paste. Yes, it is. Let's copy this. Let's get rid of this. Okay, we're gonna try this. Pearson. So it should be 3 over 7. Okay, we're gonna just kind of keep working, and these are like introductions to like concepts, and then you got to put it all together for curve sketching. Horizontal, right? We should probably test negative infinity as well. That term still goes to 0. Yeah, I think we're okay. It has one horizontal asymptote. Y equals 3 over 7. Y equals 3 over 7. Okay. All right. Let's see the time. Okay, that looks good. Okay, let's keep going. Horizontal asymptotes. Okay, let me write this one out. So I'm gonna try to do the same explanation. Just try to say it a different way. So this is question number 16, right? It's asked us to find any horizontal asymptotes. We're given this, now we have this x squared minus 2x under 7x, okay? And this is equal to f of x, okay? All right, let's inquiry, Mr. Mackey from South Park. I realize that I've been saying that a lot, and I can just see Mr. Mackey from South Park. I'm like, oh, so bad. That's so funny. Okay, find the horizontal asymptote, right? So notice, first thing is, notice that the degree of the numerator is less than the degree of the denominator, right? So we're going to have a horizontal asymptote. We don't always have a horizontal asymptote. Again, the horizontal asymptote is concerned with how the function behaves as we either go to the far right, as x either runs to positive infinity, or if we go to the far left, as x runs to negative infinity, right? See, there's a question. Let me finish this one out, check it, and then I'm going to come back and entertain the question. Um, so we're just going to do the same thing. Again, we're concerned with, we want to consider the limit as x goes to positive infinity, right? And I'm going to, now the highest power is going to be x squared. So I'm going to factor x squared from all the terms, right? So on top, if we factor out x squared, it leaves us with 7 over x, okay? On bottom, if we factor out x squared, it leaves us with 1 minus 2 over x. And that division is the main thing that we need, right? Okay, so now those terms cancel, and now we're ready to pass the limit as x goes to infinity. So again, a fixed number over a really, really large number is essentially 0, right? So this term goes to 0, this term goes to 0. This is going to essentially leave us with 0 over 1, which is 0, right? So as x goes off to positive infinity, our y value gets closer and closer to 0. And I think it's the same for the other direction as well. Okay. Let me check this in Pearson, and then I know there was a question. One horizontal, y equals 0. Okay. All right. I'm going to the next question, and let's check the question. Let's see what we got here. Yeah. So if you get into the attendance, if you make your way into my roster on Zoom, that means I take attendance as I let you in. So once you get into the session, then that means you got attendance credit. So it's not really a question. Like once you get into my Zoom, like once you're in there and you're listening to me, because I take attendance as I let you in, so you don't have to worry about that. Okay, let's look at this one. And again, so I know I did something with you all's grades. It may or may not be displayed properly, but I just want you to know that like if you see a grade for attendance, you can essentially ignore that. I don't factor attendance into the grading. I just do that for records. Um, but the grade essentially comes from the assignments on Pearson. Okay. All right, let's give this one a go. We're still finding asymptotes. Okay. So this is question what, 17? Let me see. Oh no, what happened? Don't you act up on me. All right, let me see. You look good. You are hanging in there. I ain't gonna study. Okay. So this is question 17. All right. This does come from section 3.3, question 26. I'm gonna say find any horizontal asymptotes. Okay. Let's see. Let me start with the top because that one looks a little bit longer. We got this. Either one is fine. No. This one. Oh no, I keep that version. Okay. So on top we have 4x to the 4 plus 4x squared minus 9 over. We got this 3x to the 5th. Thank you for this. Go away. Minus x plus 8. This is f of x. Okay. All right. Let's hop over to the tablet. Boom. All right. This is where we're working. So again, for horizontal asymptotes, we're concerned with how x behaves as it goes either off to the far right or the far left. So we have to evaluate absolute value of x. Okay. So now the highest power of x in this case, notice that the degree of the numerator is less than or equal to the degree of the denominator. So that means we do have a horizontal asymptote. So the highest power is going to be x to the 5th. I'm going to factor out x to the 5th from all the terms. Okay. So we want to consider, we can work here, the limit as x goes to infinity. Now, if we factor out x to the fifth from all the terms, on top, that's going to leave us with, I think it's going to be 4 over x plus 4 over x cubed minus 9 over x to the fifth. All right, that's the top. Okay. On bottom, if we factor out x to the fifth from all the terms, this is going to leave us with 3 minus 1 over x to the 4 plus 8 over x to the fifth. I just basically divided everything by x to the fifth and left it, right? So then these cancel. This is going to go to 0 as x goes to infinity. This goes to 0. This term goes to 0. This goes to 0 and this goes to 0, right? So it looks like what it leaves us with is going to be 0 over 3, which is 0. Okay. And I mean, you didn't really have to do all that. This one, you should see that, like in college algebra, we'll say things like, okay, if the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is going to be y equals 0, right? But this is like a limited explanation as to why that's so. Okay. Let's hop over here. We said y equals 0, so 1 right here. Y equals 0. Determine the horizontal, okay, if one exists. So exponential in general, the horizontal is going to be the x-axis, right? Y equals 0. If we think about transformations, we didn't move this up or down at all. So it should still just be y equals 0. Like we didn't move this up or down. So it's going to be y equals 0. And let me see if they gave an explanation for this one, because I know the other one they didn't. Maybe they don't do it for a lot of these. That's interesting. Okay, sketch the graph of the following function. Okay. All right, so I'm going to try to mimic the way I did it in the lecture presentation, because it's like 7 or 8 steps that you got to consider. And the main thing is like, let me just try to list it out. So this is question number 19. This comes from section 3.3, question 35. Okay. We're going to say sketch. Okay. And on bottom we have this x minus 6 that's under a negative 1, and this is our f of x. Okay. All right, let's hop over to the tablet, and I think we can generate enough stuff to answer the questions. So now in the presentation, like there were like about 8 different things that we need to look at. The first thing that we want to consider are intercepts. See if we can find any intercepts, right? So for instance, say I usually like to start with the y-intercept. And for the y-intercept, again, we just set x equal to 0, okay? So if we set x to 0, we get a 0, 1 over 6, okay? Then if we can do y-intercept, that means we can also consider the x-intercept, right? For the x-intercept, we set y equal to 0, okay? So so basically we're going to be setting the entire fraction equal to 0. And so when is a fraction equal to 0? When the numerator is 0. But this numerator will never be 0, so there should be none. I'm going to say x-intercept, we got none, because the numerator is never going to be 0 in this case. So we got no x-intercepts. Here's our y-intercept, here's our x. We didn't get any x-intercepts. So now, if we can set the numerator, so the next thing to consider after intercepts, we want to find any asymptotes or asymptotes. Okay. So there's like 3 for us to consider. First, let's see if we can find any vertical asymptotes. Okay. Let me get a copy of the original. Copy. Okay. So the vertical asymptotes are going to occur after we simplify the fraction where the denominator is 0, right? So if we set the denominator to 0 and solve, we get x equals 6. Okay? Because that's going to give us some number over 0. It looks like we have a horizontal asymptote because the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote, we could factor out, if we factor out an x from all the terms, ultimately you'll get, and if we do the same procedure we did earlier, you'll eventually get to, it should be y equals 0. Right? It's a horizontal asymptote. Okay? We're not going to have a slant. I know we haven't talked about it in homework, but we're not going to have a slant here. The degree of the numerator, in order to have a slant asymptote, the degree of the numerator has to be larger than the degree of the denominator by 1 degree, right? So after asymptotes, then we want to look at the first and second derivative. So let me actually just go ahead and find those guys, and then we'll start going back through our list. So if that's f of x, f prime, I'm going to do the Lodi high. All right. So if I do Lodi high, the bottom, which is this, well, the bottom times the derivative of the top. The derivative of the top is going to be 0, so that's going to be gone. I'm going to say minus, so the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of the bottom is just 1 over the bottom squared. Okay. So then this is just going to be x minus 6 squared. So I didn't write all the details of finding that derivative, but you should be able to do that one, like to find that derivative. Okay. Let me go ahead and find the second derivative as well. So then f double prime. So instead of doing it the way I did for the first derivative, I'm going to make an adjustment. I'm going to do it a different way. So again, we want to find d by dx of, if I rewrite it, I can rewrite it as x minus 6 to the power of negative 2, right? So if we take that derivative, the negative 2 comes down, x minus 6 persists, the exponent now becomes negative 3, and then times the derivative of the inside, which would be 1. So then we can kind of wrap this one up as the bottom is x minus 6 cubed under 2, right? That's the second derivative. Okay, so I'm going to highlight these. Like here's the original, here's our first derivative, and here's our second derivative. Okay, this is f of x, this is f prime of x, and this is f double prime of x. Okay, so now after asymptotes, another concept to consider are, now let's look at, this is what, item number 3. So we can consider, let's see, can we find any extrema? All right, that's like, relative max and relative mins, right? So we need the first derivative for that part, right? The extrema are going to occur when the first derivative is either 0 or undefined, right? So if we look at this fraction, again, a fraction is only going to be 0 when the numerator is 0. But again, this numerator will never be 0. So then we consider, okay, what values of x make the denominator 0, right? The values of x, there's only one value of x is going to make the denominator 0, and that's going to be 6, right? So it sounds like x equals 6 is a candidate to be our extrema. So what we're going to do, we're going to plot it on the number line. Here is 6, right? We'll consider the original function, so we'll consider f of x. And right now we want to look at f prime of x. Okay. If we plug 6 into the original function, well, I think that makes it, it's undefined, right? So it's going to be a vertical asymptote. So that means it won't be a relative max or min, but we can also, so since that won't be a relative max or min because that's an asymptote, so we won't have a point there. But we can still talk about whether the original function is increasing, or decreasing on either side of this asymptote, right? So for instance, if I choose something to the left of 6, like let's choose 5. If we plug 5 into the first derivative, notice this is negative, negative squared is positive, so on the left side, The first derivative is positive on the left of this, so that means the original function should be increasing on the left side of this asymptote. To the right of 6 would be something like 7. I think it's the same kind of deal, right? Because if we plug in 7, we're going to get positive 1 squared is still positive. Ultimately, the final result is going to be positive. So it should be increasing, right? So the function should be increasing on the left and the right side of this asymptote. So we had no extrema, no critical points, like no local max or local mins or anything like that. After extrema, and we found increasing and decreasing. Next, we consider like turning points or concavity, right? Let me think. I'm just going to call it concavity. Turning points. Turning points. Right. That's where the original graph goes from concave up to concave down, or vice versa. And this occurs where the second derivative is either 0 or undefined. So if we look at the second derivative here, again, this is never going to be 0 because the numerator can't be 0, but it is going to be undefined when x is 6. So we still consider it a 6. I'm just using the above part, okay? It's going to look a little weird. Move it up. So now if we consider f double prime on either side of 6, again, it's still going to be an asymptote there. But we want to see how does the concavity behave on either side, right? What is our concavity? So if we choose a number to the left of 6 and plug it into the second derivative, like if we choose like 5, okay, now notice here. If we plug 5 in, this thing is going to be negative, right? A negative to an odd power is going to be negative, along with this negative. Double negative eventually makes that positive, right? So the second derivative is positive on the left side, which means the original function should be concave up, okay? On the right side of 6, let's choose something like 7. 7 minus 6, this is positive. The denominator is positive. A negative number divided by a positive number is negative. Okay. Okay, that's fine. So this is, it's negative. The second derivative is negative on the right side of this, so the function should be concave down. Let's see. And then maybe just choose a few additional points, right? We got an intercept earlier. We got a y-intercept, so when x was 0, okay, so we're going to choose several points. I need this guy right here. Okay, let's copy. Okay, I want to paste. Here's a copy of the original function. I want to make a table, so I'm going to compare some x's and some y's. Some values that I want to include. We found the y-intercept, so when x was 0, we have this vertical asymptote, so that's like when x is, 6? And I'm going to just choose a few additional points. Like I'm going to say, maybe when x is -2, -1. We don't really need that many. Let me see, 2, 4, 6. So I would do like 2, 4, 6, 8. And I'm just going to do -2. I'm not going to do -1, right? Just to try to make it consistent. I just chose a few additional points out. The greens are a few additional points. The blacks were the ones that we found earlier. Now, I think when x was 6, was it 6 or -6? When x was 6, that was our vertical asymptote. So I'm going to identify that like with the dashed line to show that's our vertical asymptote. When x was 0, I think we got a positive 1/6. If we plug -2 into the original -2, that's -8. So positive 1/8. Okay. If we plug 2 in, that's going to be what? 2 minus 6 is -4. So then 1/4, positive 1/4. Okay. This one is a -2. So it's a positive 1/2. Okay. And then something like 8. So these are getting closer and closer. These should be going. Yeah, these are starting to move away. Like if we chose something like, as the closer we get to this line, it looks like it's going to go to positive infinity. It's going to go up. And then on the right side of 6, like if we choose 8, it's going to be a negative 1/2. Okay. So then I'm going to plot these. X is, okay. So here's the origin. We just need to get like 10 there. What about Y? We need to go positive and negative. Okay, X's, let's get over to 10. So if we go 2, 4, 6, 8, 10, is that too jammed? It is for me. So I'm going to space this out. Let's see. 2, 4, 6, 8, 10. Okay. 2. Okay. And then the Y's. Let's go up to like 4. Let's go like 1, 2, 3, 4. 1, 2, 3, 4. Okay. So our positive X is here. That looks good. That looks good. So positive X is here. Our Y. That's decent. That's decent. This is positive Y here. This is the origin. I think we said 2, 4, 6, 8, 10. This is negative 2. We call this 1, 2, 3, 4. These are negatives. 1, 2, 3, 4. Okay. Paper. I'll check my time. Hopefully you guys are okay. I know it's like intense. Oh, we definitely lost some troops. We don't have much more time. It's okay. Okay, let's keep going. So let's plot these points. I'll plot them in blue. So some other things. We got a vertical asymptote with 6. So let's go ahead and do that one. So like here. And then what I'm going to do for that. This one a little bit thicker. That's good. And this is what, x equals 6. Okay. I think we had a horizontal asymptote was the x-axis. We said y equals 0. So what I'm going to do is like this. Style. I want it like this, like this. A little bit thicker. Okay. So horizontal asymptote was what, y equals 0. Okay. Then we can plot some points. When x is 0, here. When x is negative 2, y is an 8. Let's see, that's a half, quarter, an eighth is like here. When x is 0, we're at a 6. So let me see. If that's 1 over 2, so 4, 5. So it's still about like here. Something like that. When x is 2, we're at a quarter. So we're like here. When x is 4, we're at a half. So that's here. Like if we did 5, okay, well, I'll show that in a moment. We got a vertical asymptote, and then when x is 8, we're at a negative 1/2. We are like, I think it's like here, all right? So now with these asymptotes, all it is, on the far left, we start close to the asymptote. We just start close, we pass through our points, and then we finish close. Okay? And then on this side, we start close, we pass through our points, and we finish close. All right? And we get an image like this. Okay? And like what you could do is just find a few more points. Like, okay, we can say like when x is 5, when x is 5.5, right? You can get like a whole bunch of other points. So we got an image like this. Let's check some other things real quick. We said on the left of the asymptote, it should be always increasing. So notice as we trace this left to right, it's always going up. And then it goes on the left side of the asymptote is concave up, on the right side is concave down. So those two hold. Those are the main things I wanted to verify. We have our y-intercept was 0. It all checks out. Okay. All right, so now we got an image like this. Let's hop back over to Pearson and use this information to answer the questions. What intervals is it increasing and decreasing, right? So if we go back, it's increasing everywhere except at the, let me see, it's never decreasing. Radicals, okay. So it's increasing over the whole line from negative infinity up until what, 6? And then unions, I'm going to put cup 6 to infinity. So basically on the left part of 6 and on the right part, right of 6, the function is increasing, INF. Okay. All right, let me see, what do we do? We said it's increasing. Let's see. Oh, commas, right? I did it in interval notation, so comma. Okay. Determine the coordinates of the relative extrema. I don't think we got any extrema. So we got that there are no relative extrema. Look at the, yeah, there's no local maximum in. Okay. Vertical asymptote has 1, was x equals 6. Okay, 6. Okay, what's the time? 7:15. Okay. Horizontal asymptote, I think we got the x-axis was y equals 0. Okay. Slant asymptote, there are none because we said the degree of the numerator is not. In order for there to be a slant, the degree of the numerator has to be larger than the degree of the denominator by 1 degree, right? And that didn't happen here. Okay. Is it concave up and concave down? So it's concave up. Okay. So it's concave up on the left side of 6. So from negative infinity up until 6. And it's concave down from 6 to infinity. 6 to -. Okay. My stuff is like hanging on by a deer thread somehow. I think I'm probably just gonna call it a day after this one. I don't know that we're gonna have time to do another one of these. And this was a light one. These get worse, way worse. Determine the coordinates of the points, but it's doable. You just got to take your time and space it out, like it really is. Determine the coordinates of the points of inflection. I don't think we had a point of inflection, even though it went from concave up to concave down. It it wasn't defined, so there are no points of inflection. Okay. X-intercepts. Do we? I don't think we had any, so there are no x-intercepts. Okay. And then the y-intercept was 0, type an ordered pair, 0, comma 1 by 6. Parentheses. 0, comma 1 by 6. Okay. Okay. Is that it? Okay, and then the graph. So it has to be either B or D. What's the difference? Oh, concavity, right? Or just basically the region that's highlighted. I think we said B is what we got. Yeah, let's go with that. Okay. All right. So because this, for the sake of trying to honor the time, because I feel like if I do another one, we're definitely gonna run out of time. I'm gonna rush. Uh, if you want to see, just let me know. Otherwise, just kind of do the best you can. So hopefully you all are like working together. Hopefully you've been able to link up with tutors. Let me hop over. Let me do a few little housekeeping things. So first thing, let me go ahead and share a little paper. Get rid of these lines. I'm gonna go ahead and send you a copy to Box. You can access it from Blackboard. the notes that you saw me taking, it should be available. Right? So I just loaded it just now. Okay. Uh, yeah, the main thing is like I would do the best you can. You've already paid for tutors, it's including your tuition. I would definitely link up to tutors. Make use of like the Ask My Instructor, like if we look on this question help. Now see this one has like view an example, video explanations, like so many of them didn't. But yeah, you're not always guaranteed the others, so just but the Ask My Instructor, it comes in my email. I know my explanations are what they are, but it's okay. I can't think of anything else. So we're just going to kind of go ahead and wrap up from here. And on that note, we're going to end the session here. Let me check the chat real quick. I don't think there are any questions, okay?